No, thanks for the invite, and also thanks to you for attending after lunch. So hopefully, I should be yeah. Hopefully, it is interesting to wake you up, right? Okay, this date should have been changed, but yeah, as you can see, I want to. The title says "Text Chance to Humanize," so I'll little bit zoom into that part. I think Gen AI, all of you have heard. I don't want to go tell you here is what a large language model is, here is how it works, and so on. The intent of the talk is to somehow talk about how, with these technologies, you can reimagine what can be done with them, right? So it's more at the application level. And I genuinely believe that we should look at tech with a slightly different lens now with these models coming in, right? So normal tech as well, and of course the new kinds of things that we can build with these models, right? So you please focus on that word humanize, and let's see together what we can do it with it. I think we have a fairly long session, I think 1 hour. So I'll try to keep it interactive. You can also please keep it interactive. Let's just have a conversation. Please ask questions, please share comments as you go through. Just to get a sense of the room, how many of you, of course, how many of you have used GPT? I'm assuming more. How many of you use some chat GPT or something like that? Almost all of you have done, right? Yeah. Any interesting use cases? What do you use it for? Anybody just wants to say? Of course, all of us use it just for some random research, but any interesting use cases? Yeah.
I'm trying to get my house painted, and had a lot of challenges with the workforce. I speak Tamil, my mother tongue is Tamil, so tried to have a conversation in Tamil, hoping I'm going to get some issue or something like that, but it was spot on.
Okay.
Tried in Hindi, tried in Marathi. So to me, really, how do you manage a workforce which is not,
Yeah.
say, organized sector?
Yeah.
Was pretty profound.
Yeah. So breaking the language barrier that's an interesting thing. Any other use cases? Yeah.
More from a corporate perspective.
Yeah.
The analysts today, basically have to read through a lot of earnings reports
Mm.
and do the competitive analysis.
Mm.
I think GPT is a blessing in disguise. The right level of prompting, analytic pre-processing, it's really able to get to 90% of accuracy.
So things like the regulatory filings or even other kinds of documents?
Largely more on competitor analysis.
From the web itself. Okay. Yeah. Okay.
Just to add to that, same point, also looking at internal policies and procedures, and normally they are scattered across various documents. It takes a lot to really find out all the links to the right documents, having the same mention of the word or the phrase that one is looking for. So that is a huge use case that is coming up in our organization.
Interesting. Okay. Whether it's external information or internal organizing it, and anything else? Yeah.
A lot to clean up data. So you have
Clean up data.
really look up things, and especially NLP side, so where there's like you have to look up, create your own rules. It's quite easy that you just feed it in.
I'll talk briefly about that. That's a good use case.
Pratyush, I'm not sure if you would cover this. Maybe in your session, if you could help us, because every business line is trying to jump into saying ChatGPT or GPT-4 is my solution for classical AI ML problems.
Yeah.
I think I come from the innovation digital transformation side, and we're struggling to make them understand, hey, this is not a magic wand like a Harry Potter you can swipe to solve problems. You have to think from a classical way as well at times. So maybe some direction towards that, so that I can take it up and speak to my corporate heads.
Yeah, I don't know how much I can help, but I can tell you that I'll talk a bit about the art of product. I don't know why this keeps going forward. Right? The art of product, which is, how was software built earlier, and how should we think about software now? Right? It's if we had this superpower, it's a transition. It's a big one, but many things that we did earlier also still apply. Right? And what is the playbook? We'll talk a bit about it, and you can ask me questions as we go. Right? Any final comment before we move on? How do you use GPT in creative descriptions? Yeah.
So the time and efforts it goes for a traditional machine learning model to master it, to tune it, to get that accuracies. I think that learning curve as well as the time to get the results has tremendously decreased with the help of Gen AI, I think.
Right. That's interesting. So what he's saying is, as an expert, I would want to train machine learning models, right? And that also becomes faster because you have access to these models, right? Yeah. All right, great points, and I think please keep it interactive, ask doubts as we go. I wanted to first just recognize one thing, right? I think you do, but it's just good to put it in a slide, put a picture to it, and see what it means. On the x-axis is size, on the y-axis is value, right? You're building something, and you make it bigger and bigger, and what happens to the value of that, right? So if you take a hammer, right, what is happening with deep learning is, there's this hammer of deep learning, and as we made it bigger and bigger, right, its value kept increasing. By bigger and bigger, what I mean, yeah. We'll just let these people come in and then we'll. Yeah. So yes, please come in here. So what has happened with deep learning is the size of a deep learning model is the number of free variables in the model, right? How many variables can we tweak around for it to do what you want to do, right? You want it to learn to do something, and you have some free variables to do it. That how many of them are there is what decides this size, right? And you might have heard things like, Llama model is 7 billion, some other model is 100 billion. They use the word parameters. It is how many free variables there are to change, right? And that is the x-axis. As you made something bigger and bigger, its value increased. So this we saw, 2009 was the first time when things like computer vision models took off, where you could use deep learning methods to make them work, right? Earlier what people did was, if you were building computer vision, like detecting if something contains a cat or a dog, then you would try to understand computer vision differently, understand what is an outline, what is an eye, what is a nose, and then build models, right? But with deep learning, we came to an era where I can just show it many, many pairs of images and the labels, that is, this is a dog, this is a cat, and so on, and it learns, right? And that era, we saw this happening. As you made the model bigger, the value increased. But what has now happened is something like this happened, right? Suddenly you made it a little bit more, and what we call emergence. Now this value is significantly higher. This is what happened with what you experienced with ChatGPT, but internally happened in OpenAI at 3.5, GPT 3.5, right? In fact, OpenAI's main achievement, they of course tried various things. They tried reinforcement learning, robots, and so on. They failed. This was their main expectation, that indeed if you made it bigger, this would become valuable, right? And now contrast this with real life things. If you take a real life hammer, this is a big convention center. It was not made with a big hammer, right? The hammer sizes are still the same. We don't have a parallel where, as human systems, we have built something bigger and bigger and bigger, and it got better and better and better, right? And this is the bet of AI, that it is simply a game of scale, right? It's not like there are clever ideas that went from here to here to here to here, right? But they're not Nobel Prize winning ideas, right? But we got something that is dramatically better, right? And people believe we are very early in this cycle, right? So there are hammers way above there, which would be even more powerful simply if you make the model larger. Right? I just want us to recognize that. That is what we are. Let's say for somebody who is a bit skeptical, right? Oh, this model is making these errors, it's hallucinating, and this and that, right? Look at this picture, right? Tomorrow some model will come that is 10x better because it's larger, trained on more data, and so on. So this is the argument for why this is a very interesting technology, and it doesn't have a parallel in other things that we do typically, right? Okay, so this is what we used emergence. Emergence simply because even for people like me who are supposed to be in this area, we didn't see it coming, right? So it somehow emerged that at certain scale, new abilities became possible. And there's a nice diagram to capture that. Somebody mentioned NLP tasks, right? NLP stands for Natural Language Processing. This is a animation from this website, Assembly AI, which is also a startup. What this shows, it's a little bit dated now, but it shows the idea. These numbers don't take them exactly literally, but the point is, if you had a model which is about 8 billion parameters, it would be able to do things like language understanding, which is, by the way, an easier task. If I speak something, can you make sense of what I said, which is easier than generating tasks, right? It can do some basic arithmetic, it can do some basic question answering, and so on, right? And you'd be surprised to realize that all these three were different aspects of research. They were not even done by the same professors. Somebody studied natural understanding, somebody studied how to do arithmetic with models, somebody else studied how to do some other particular task and so on. But with 8 billion parameters, already some kind of models do this, right? If you extend that, again, don't go by the literal number 62 billion because things are changing very rapidly. The tree of abilities of these models becomes so much more, right? You can do summarization, which, by the way, is a great proxy for intelligence. Right? If you can take a piece of, somebody mentioned reports and so on, right? If you can take a piece of text and reliably summarize it, get the essential ideas from it, it's a great test of knowledge, and many models right now are very good at this, right? Things like code completion show up, very different area. I mean, a lot of work happened in computer science and understanding code and so on. Now, large language models predicting next word can do code completion. Nobody expected that, right? Translation, even common sense reasoning, which you would say requires knowing about the world, all of those things also show up. And if you do it even bigger, 540 billion parameters, a lot of other tasks come in. For example, can you understand proverbs? Right? Can you understand things like joke explanations? I mean, somebody mentioned creativity, right? We think that, yeah, it's very interesting. What do you think you do, which is something that these models would not be able to do, right? It's a hard question to answer, right? The water level of these models is rising so fast that we need to really question that carefully. Things like physics question answering and so on, right? So this is, I think the point is clear to all of you. As these models get larger, more of these abilities come up. And also notice that it somehow becomes cross-cutting, right? If I train the model on physics, it gets better on jokes as well, right? That's also one thing we are noticing. There is value in centralization. Show all the data to one model. In fact, why all types of data, even all languages, right? I can show it Marathi data, Hindi data, I can show it English data, and it starts getting better across all of this, right? So we're not necessarily specializing. There is a case to be made for domain-specific models, which is if you knew that you want to use a model only for summarization, can you start from a model that is like this, which is generically capable, and then make it smaller and still good enough on summarization? There's a case to be made for that, right? But in the race for AGI or whatever, the goal is throw all the data into one model. In fact, now it is not even text. Can I even throw things like IoT data, natural sciences data, and so on, and make the model understand more of the world, right? All right. So what I now want to do, see, because I think to some extent all of you would understand this, maybe it gives a bit more color to it. Yeah.
How does one explain 540 impact billion parameters? Can you just track your a common understanding of what a parameter?
What a parameter is, right? Yeah. So take for example, take the simplest case. I say I give you 2 points, right, in space, right, and I want you to fit not even a space in a paper, right, and I want you to fit a line to it, right. Fitting a line to 2 points can be done, right, and this line is specified by exactly 2 variables, right, which is the slope of the line somewhat, right, and where it intersects the y-axis. This is what we study, right, linear regression. I can fit a line to 2 points with 2 free variables. If I can decide these 2 variables, m for slope, c for intercept, I can fit it. So that would be an example of a 2-parameter model. Okay. If you go to a cubic model, I can fit data to a cube, cubic spline or whatever, 3 parameters, right? Now bring it all the way to this. There is a model which has 540 billion free variables, which I can tweak such that the resultant model is good at the task I want it to do. Things like summarization. Right? Actually, it's not trained like that. It's trained somehow differently called next token predictor, which is can you predict the next token, next word, when I show it. But these are the variables that are all changing in response to that requirement. Right. Anything else? Any other question?
I just want to know, compared to a human brain, this processing of all this data is equivalent to how many brains?
Yeah. I think we have not understood even one brain. That's the challenge with us.
So what I mean to,
Yeah.
I'm asking that because the way things are going,
Yeah.
I mean, this is displacing, disrupting the requirement of intelligent person by human, right? So, in the future, what's the value addition according to you? I just thought you know downstairs this one. And what's the human going to do in the future?
Yeah. Yeah, that's a very important and open question. But to your point, right? We have in the brain, it works a bit differently. It's analog circuits, right? And there are neurons and there are synapses which connect them. We have even more synapses than there are parameters here. They're in the trillions, right? They're the brain, and the nature's engineering. We're able to pack that so much more efficiently, and in fact deliver power to them so much more efficiently, right? So we are, I think, 3 to 4 orders of magnitude less efficient in the digital systems today, right? But then the brain had to scale to whatever is the restriction of the human body, and this doesn't have to. These are limitations, right? You can have one system that's running on tens of thousands of GPUs, and my sense is that I think all reasonable tasks that we think we want to get solved will get solved. Right? We'll really struggle to say, hey, here is one thing that most humans are good at. Of course, there will be experts in different fields, but most humans are good at that an AI system cannot do. I would be surprised if by 2030 we can make that claim. Right? Yeah.
There was this definition of singularity, right, which was predicted somewhere around 2042, which is exponentially coming closer as well. Right? Now it is predicted to 2037, which says that one model would be equivalent to all brains put together on the world, right? So is there some truth to that? Have you heard anything about it?
There are various things that float around. There is a one formal survey that is done of different researchers on asking when we will hit what is called artificial general intelligence, where models get generally capable at the human level for most tasks, right? And the survey is done, where people are asked when that will happen. And if I was asked, I would say 2030, like I did now. And different people say different things, and it's a range, right? And it keeps varying, as you said. I don't know what the exact numbers are, but there's a formal survey, and I think it is in the 2030s, from what I remember, that we will be able to solve most tasks at human level. But all this is worse than stock market trading, right? Nobody knows, right, what's going to happen. Even as I said, emergence. Look at the word. In engineering field, we are saying emergence, right? That sounds like we don't know, right? And we have to figure out what will happen. Okay, all right. So I hope you got that point. What I want to do is, I just want to a little bit tell about what we are doing in Sarvam, which is we are trying to build these models for Indian languages, Indian contexts, and also in applications that you and I care about, right? For example, what does that mean? Of course, Indian languages we all understand. We have a rich set of languages. In fact, it is so interesting how rich linguistically India is. Look at anywhere else in the map. So many scripts, so many dialects, so many languages, just not there. So India is a super hard language benchmark for AI, right? Whatever AGI, whenever you have to get it right, you have to prove that Indian languages are working well. It's a very rich linguistic country, right? So Indian languages is definitely important, right? The second thing is Indian context, right? Indians maybe focus a lot more on education. We spend a lot of money even in the various, across the segments to learn, right? And we today don't have the capability to provide education, good quality education to everybody, or healthcare to everybody, right? Then third Indian context is India stack, right? Again, we might be surprised how India stack is actually serving the country at scale, right? Because you have things like Aadhaar, UPI, because you have account aggregator for bank statements, likely soon things in the medtech space and so on, we will at least have the plumbing ready for digital things to scale at population level, right? And that is what is required for AI to then flourish. If you have the plumbing, data is flowing, standards are there, right? Then you can build things on top, right? For example, building a Gen AI agent which can look at your bank statement privately for you and tell you what you should be doing differently, right? Or actually take national curriculums and build some kind of tuition assistant for you on the go, right? These are genuinely possible, right? And so what I want to do now, I'll have to quickly go through this. I want to show you 5-6 examples of what is possible already, right? And I think to your point about what the leaders are thinking and so on, I think we need a lot more imagination on what to do with this technology. It's been a year now, this has been out there, and people are trying various ways of productionizing it, but the kinds of things you can do with it are actually tremendously more powerful. Just want to show you a few examples, right? One simple example is a high school student asks LLM to generate a discussion between Hanuman, and interesting there was some Hanuman there as well, right, today. Hanuman and Thanos, of course, from the Marvel series. And you ask this, by the way, the image is also generated with DALL-E 2. Now I should use DALL-E 3 and it's much better, but this is already a few months back, right? And what is happening here is education is bottlenecked by some people creating content, And that content goes to everybody. Of course, that funnel of content increased because you have YouTube and many people made videos, right? But it is still gated by what a teacher or somebody feels I should teach somebody, right? But with generative AI, the student, just maybe this guy went and saw the Thanos movie, or maybe studied about Hanuman from his grandparent, he can bring two things in his context of his life together and have an educational experience, right? Nobody needs to have thought about this question at all. That somebody will ask about what will Hanuman talk to Thanos and design for it, right? But the generative AI is capable of bringing these two ideas together, right? So, and this is the question. In fact, I don't have it here, but can you get a beautiful answer from what Hanuman will talk to Thanos? They talk about dharma and so on. Of course, Thanos, I don't know if you see in the movie, he goes into a dharmic conundrum whether he should kill half the population or not, right? And you can have some kind of a follow-up like this. Of course, this is little bit of a toy example, right? But the point being that students and individuals having their context in life can on the fly synthesize assistance on their learning, right? And you can ground this. You can ground this on the textbook, you can ground this on the video that you're learning. Let's say you're looking at the very, very popular physics wala videos, right? It's a static video, you're consuming it. Can I pause it now and ask a question? That is grounded in what the JEE syllabus is, right? Or can I ask about, hey, I got this thing wrong, I see some solution here, can I get it right, right? And there are some technical things to solve it, and many people are very busy solving it. We are also doing that. But I would be very surprised if technically by the end of 25, we don't have a very solid, simple solution to things like this, right? So who are the guys who will go and then design systems like this, make it work at population scale in the country is the question, right? I'll do a few of these examples, right? So another example is a farmer speaks in Punjabi to a voice call system to answer custom queries reasoned over an English document. So there is governance that happens in Delhi. Unfortunately, we are still a very centralized country, but Delhi or wherever in whatever Punjab, the respective capital, and somebody decides something, there is some document which is the policy. Now, how does somebody access it, right? And you can today, we have a system running at Sarvam where you can do a voice call in your language, and within less than a second, receive a response, which is coming from an LLM system, right? So it recognizes your speech, it intersects with an LLM, grounded on some English document, and gets back a response in voice back to you on the call, right? And I would be surprised, again, if in matter of a year, we don't have systems which the bot answers better than humans, right? Because for bot to understand the context of a particular user is a few hundred tokens or whatever, a few hundred words, right? But if I am a customer care executive and I picked a call from one of you, right? I will get on my screen something, this guy is this guy has this profile, this, that. They have to empathize, they have to understand that, right? It's a very, very challenging thing, right? So bots being able to consume, understand personalized information, be able to do reasoning on English, but interact with you in your language, right? And do it in real time, I think is a possibility. For example, I farm on 4 acres, am I eligible for PM Kisan? PM Kisan scheme is there. It actually then tells you yes, no, whatever is the answer, right? And in fact, this is information access. But a simple extension of this is action orientation, right? Which is say that, hey, can you actually go fill the form for me? And I was talking to somebody in the other place, we should simply kill forms. We don't need forms. I don't know why we have so many forms, right? The information about me is in one place most of the time, and I should have agents which are able to then represent me in doing things like filling forms, right? And again, genuine possibility, and the cost of doing things like that are falling tremendously. Many people worry about, hey, these models are expensive, right? But they're expensive today, and if the way things are going, they'll become super cheap in very, very soon. In fact, they're becoming cheap as we speak, right? So that's the second kind of an example. A third kind of example, a domestic help converses with an LLM bot, I think it should be does her finances without knowing how to operate a spreadsheet app, right? You and I can use spreadsheet. We can go to Excel, Google Sheets, whatever, right? Again, there's a bottleneck. Some people know it, some people don't know it, right? In fact, even the Microsofts of the world and Googles are trying to make their sheets Gen AI first, right? But imagine what is the power for this lady if she asks, this is a Kannada statement, if she says, I earn 20,000 rupees per month from May, it'll increase to 23,000. It'll increase to 23,000 from July. I currently have so much savings and my monthly expenses is this much. By the end of October, how much can I save before Diwali? right? If I ask a question like this, of course it looks a bit complicated here, but actually if you speak it out, it's very reasonable. You can use colloquial language, you can use code mixing, English words, Hindi, Kannada words, in this case it's a Kannada example. And an LLM is capable of not only understanding intent, translating intent to the fact that it can use an Excel or code interpreter to actually execute this intent and give you back an answer, right? So this bottleneck of who used spreadsheet, right? And in fact, the fact that you even need to know that I can use spreadsheet, right? That should again go away. Small and medium businesses, can they do their books very differently? In India, GST at least is fully digitized. If you can make calls to the GST APIs, you get all the information around the taxing that at least the government is working with, right? But it is such a pain, right? Every business is facing so much pain to do this kind of thing. Can we have LLM-based systems that make processes like that easier, right? Example of a bottleneck in using tools. This is an interesting example. A non-programmer, of course, by now I think all of you have understood this, but you can create images. But the interesting thing here is that I wanted to create a Rangoli image, right? And Rangoli image is interesting because I don't want to see a very, very rich graphics. I can't go and draw that out. Rangoli image requires a line art, right? And then I can go and fill it up. And it turns out, if you say something like in Hindi, and you can then generate code which will draw the line art. I'm not generating image. I'm generating code that will draw the line art. And it's very interesting if you see this thing here. It's actually in code. Of course, many of you might be coding. It has a loop that draws these brackets around, right? And understands that you can draw brackets and get things like this. And these motifs are also related to the festival in question, right? A bit of, again, a toy example. But again, I mean, this is, by the way, this uses something called LaTeX for the code involved, right? Who would know LaTeX and use it for Rangoli, right? But again, something that these models can introspect, they can help you out, right? One final example, and this one's something I like a lot, which is because it addresses the challenges we have had in the 2 decades of the internet economy, right? Everything around advertisements. So here, a user of a video website builds a personal recommendation engine based on his nuanced preferences. So by the way, how do the internet companies represent us, right? As a big vector. Right? This person is this vector meaning a vector of numbers, and then says that, okay, this guy's vector looks similar to this guy's vector, so I will show them similar movies, right? That's how recommendation systems work, right? And that is because we have taken humans and brought them down to numbers, right? And these numbers are, of course, they work very well, efficient algorithms, they process this over billions of people, and the companies that are able to aggregate this create these two-sided markets between those who have content and those who have attention. And we just match this, and they become the largest companies, right? But I think we have an opportunity to change that, to retain human profiles at human interpretable levels. A person is not this vector. A person actually has a description. This person is an ambitious, 18-year-old. He wants to create startups. He lives in Ludhiana. He goes to school here. And he's interested in basketball. And he hates Bollywood or whatever. I'm just making this up. But that is the person's description, right? And an advertiser, maybe in a permission system, gets to see that. A user in a permission system should be able to edit it, delete it, right? And marketplaces should be able to combine advertisers and users and profitably show matches, right? And that is what this was about, right? So if I gave I was at that time seeing this Mandalorian series, which I like a lot. It's a little bit of a sci-fi setting, but this guy says, I like this Mandalorian series because it is sci-fi setting, and I like the sage-like nature of the Mandalorians. I also like the father-son dynamics at the center of the stage, and I did not quite appreciate the fight sequences, which amounted to not much either drama-wise or in weaponry, right? Whatever. Somebody writes a very detailed feedback about something they saw, right? And this contains much more about this person than 25 clicks on YouTube, which is what is used today to represent humans, right? And if you could appropriately use large language models to, first of all, represent what users are going through across experiences and have aggregate profiles of them, and then surface it for recommender systems to then show better, okay, now I understand what you do. I'm not going to show you movies that contain stupid fight sequences. So for example, right, I know this, and if I have a good profile of the movies also, and I have good profile of what are the directors who are doing what kind of stuff, you can actually make better recommender systems, right? So I'll pause there. I just did I had one more, right? Yeah, maybe I'll just finish this and I'll pause, right? This is somebody mentioned machine learning, right? So far, I mean, I don't know if you got it, but I'm trying to make the examples more and more complex, right? Initially, it was just information access. Then I can use a spreadsheet. Then I can actually do recommender systems. The last one is I can even create machine learning models, right? Who was making machine learning models, right? Very few people became whatever, very huge salaries and so on. But actually here, a girl can create a sign language interpreter where she says, this is my sign for so-and-so, and gives few images. And models can actually then be trained to detect that this sign means this word, right? And the notion of programming, which is we write code to instruct computers, was replaced a little bit with machine learning, where we show data to instruct computers, is now changed to we instruct computers directly, right? This means this, right? This means that. Show 5 examples, and now the models are capable of reliably being able to solve for that problem, right? So I'll pause here. It was a bit of a longest monologue, but I just wanted to reflect a bit on these 5 examples. And maybe if there are questions, comments, we can take them, and then before we go to the next section. Can I have water? Oh, it's here. Yeah, sorry. Any questions, comments? Yeah.
How do you judge the response is right or wrong?
That's a good question. How do you judge if the response is right or wrong? So currently, most systems are being used as if they are repositories of knowledge. These LLMs, right? But I think in the long run, that will not be the case. These LLMs will be seen as an interface between us and knowledge, but the knowledge itself will be separately available also, right? For example, if I ask GPT, only answer based on Wikipedia, right? What you might have heard as retrieval augmented generation, it's possible to do that, right? And so I see that these models will become less knowledge sources, more interfaces, and you will choose the appropriate knowledge sources which you want to support. And that's why it's important to create our own knowledge systems, right? Independent of the LLMs, to have knowledge systems which we constantly create, refine, and so on. Even for a company, what is the knowledge base for the company just became more important, not less important, because there is an LLM, right? So I think that is an important distinction that we made here.
Of this model results?
Yeah, those are good questions. Accuracy, as we have done in machine learning for a long time, will be benchmark driven, right? Every activity that you take up here, I'll use this models for this particular task, requires us to create a good benchmark for it. Here are a few example questions. Here are what we thought of as ground truth answers. How far away are the actual answers from that, right? That's hygiene, right? But from a systemic perspective, the way you get to higher accuracy would be to do things like grounding on knowledge bases, right? And answering with references to knowledge bases. So these models becoming actually domain agnostic, but still relying on domain specific knowledge will be how we would use these models, right? And you can use these models repeatedly. See, one thing that's not mentioned here is that it's not like I have to call a model once, whichever is favorite LLM. I can call the model, I can ask it to introspect its result, I can get another LLM to see the result, all kinds of things that are being done. There are models being built just to be better at faithfulness rather than creativity. So I think it's a broad spectrum of things that will come out here. Yeah. Yeah.
But if the model is in production, right? Now, for example, if you take the last example, right, like the deaf girl, right? So in that time, if suppose your model is not giving the correct result, so how you take, that output as a experience to retrain your model? Because training is easy, right, in the non-product environment, but in actual, the real time, how you retrain the model?
Yeah, that's a very good question. Again, it's good to see the parallel in the last decade of AI, right? What people did was they released these models. Let's take something classical like translation, right? I want to translate from English to French, right? And Google Translate would put out a free website like translate.google.com. Everybody will go try things out there. And then when things go wrong, they will have a thumbs up, thumbs down button and people can click, right? And they will wait to aggregate 100,000, 1 million inputs, and then go and fine-tune these models based on that feedback, right? What is happening now with these large models is that they learn faster, meaning they can learn even with far fewer samples. Right? What was 100,000 then to train the classical models could be 1,000 now. And if you show me 1,000 examples where I'm failing, these models are able to then generalize. That's what they do, they generalize. So they generalize from the failure cases to other potential failures they may be making, right? So in that sense, they are more data efficient. This has to be done. You have to take feedback. And in fact, ChatGPT asks you to do that. As you get the answer, it asks you to do thumbs up, thumbs down. In fact, they have people they employ to do that extensively, right? So that is definitely part of it. The only thing is that it might even be faster now, the amount of data you need. There's a question here.
Yep, Dr. Saab, in the previous session also, you, Dr. Ganesh and yourself discussed about creating a LLM for our country.
Yeah.
How are these models being built? And in the initial part, you also touched upon the parameters, as the more the parameters, the better the model. So how are these being developed? How are these being built as in the approach? And
yeah, so see, the way these things work is there are 2 or 3 broad ways of doing it, right? One is you take an existing model, right, that's in the open source, and then you extend it to be efficient and accurate on Indian languages, right? Another approach, what people call from training from scratch, is you go train a model from scratch, right? And a third approach is you don't do that, either of this, but you add language as a wrapper on the outside and use English as a reasoning engine, right? These are sort of broadly the 3 approaches, right? And different people are doing different things, right? What is clear is that if you use one of the existing models like GPT for Indian languages, they are very expensive, they are slow and not accurate, right? So you definitely need to change the architecture of the model, right? See, for example, if I fine-tuned a model for healthcare, that involves simple fine-tuning. But if you wanted to add Indian language skills to a model, that requires changing the model for it to be efficient. So you cannot fine-tune it as is. You have to actually go and create efficient structures to encode Indian languages, right? So that's, I think, the place where most of it is. But all of this depends on the raw material of data. And you need data on Indian languages. It turns out that you can easily find 2 to 3 trillion words of high quality English data on the web, public sources, right? Gutenberg and this and that. But in the Hindi side, or Indian language side, even after 10 languages, you can probably get to about 50 billion tokens, right? So what is 3 trillion there is 50 billion. So it's 2 orders of magnitude less, at least, right? So one of the key bottlenecks is how do we unlock more data in Indian languages? Because no matter what the methodology, you still need the data raw material to train these models, right? And there, the thing that comes up in greater focus is, okay, if it is not there in the public web, which by the way is mostly repeated news content, the same news in 10 different websites and so on, right? Then we need to get it from other sources, right? There are 2 other important sources. One is books, which encode a lot of data, where you can OCR content from, or there are videos, which actually is the leading edge cultural fingerprint of what India is doing. It's in the videos. There's a lot of Indian language videos being created. So there are methodologies on how to take that data. Again, you need AI there. How do you take a video? How do you take a book and actually extract high quality content from it to then train these models, right? So I think that's where the thing is, right? But the other point to be made is we need to think of the use cases for which we will deploy this model and hence make the models good for those first use cases. Because if you see how GPT started, if you were to, in the early days, you would see some 5 boxes or 6 boxes saying you can use it for summarization, I can use it for this, that, and so on, right? And those are the use cases where they decided to focus and get it good enough, right? We need to build a good sense of what we will use these Indian language models for. Clearly, we're not writing emails in Telugu, right? That's not what we will use these models for, right? Or I'm not trying to do completion of some message I'm writing and so on. What will India do with Indian language LLMs, right? And hence creating a leading indicator of what data sets to be created for that, right? And fine-tuning the model. That's all the other game. So I think there are these 3 pieces. One is the architectural choices, model choices. How do you get the raw data? And how do you think of use cases and build enough examples there so that the models get better, right? And different people are taking different bets. Yes, you can do that. The question is, can I? Yes. Yes, yes, yes. Yeah. Yeah. So the question is, why don't you take the few trillion tokens of English and translate it, right? Two problems. One is the translation models are not that great, right? After maybe Hindi and a few South Indian languages, they also struggle. That is one. And two, even when they work, you are restricted by how a small model, that's translation model, thinks about generating Hindi, right? So you're inheriting the limitations of that small model and putting it on a very large model, right? So, but you're right, translation is a direction to consider, but we need to play lots of tricks to ensure what are called, you don't have what is called the inductive bias of the small translation model, right? How do you ensure that it is generalizing and generating very rich Hindi content and Telugu content and so on? Secondly, see, the translation models may be trained on formal language, right? Again, what we want in India is be a bit use case driven. So when we put out the first models and we sent it to people, they found the language it generated was unusable, right? It generated some Hindi and nobody understood what it meant, right? So we had to go back and actually train it again on informal language, right? And there are no translators for things like this. So you have to create that ground up. So these are the kind of challenges that you have when you want to scale data, right? But some combination of these will work, right? Across videos, across text in English, across the web data and so on, right? Yes, any other question? Yeah.
So for all the image generating LLMs, they have a common trait around that they mess up the fingers. So if you give a prompt, they can manage the rest of the complexity, but just by looking at the fingers, I can figure out whether this image is AI generated or a true picture capture. My question is it deliberate? Is it
deliberate? No, I think it's an artifact of training these models. Its fingers are very, if you think about it, right, the density of information is very high. A face is generally very smooth in sense. Fingers are very high information dense regions, and these models struggle to learn, right? But then that was the case last year. Now you have very good models that do very well, even on fingers, right? Whether you look at Midjourney V6 or the new DALL-E models, or the latest Sora video generator from I think they do fantastically well already. It just was a difficult sub-problem, which now seems to be solvable.
So I just met a company called Envisioning.
Yes.
They can generate a video of 50 minutes.
Yes.
So I can make my own ad of my own company or make a study of tourist attraction. I mean, it's like amazing.
Yeah, 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 absolutely.
20 minutes, not like 2 minutes, 20 minutes.
Yes, yes.
And for nothing, fraction of cost. $60 is the main pattern and practice. I mean, if you're at the bottom of the J curve, I can imagine in 3-4 years what's going to really happen.
Yeah, I think that's what we should all be looking at very carefully, right?
That's why I asked you, what's the value addition in the future? I mean,
Yeah.
what's really going to happen? Because
Yeah.
today, your chatbots displace so many call centers in one
Yeah.
shot.
Yeah. No, true. One is the world is inertial; it will move slowly. I mean, at least I think that people are not reacting fast enough to what is coming. It's going to hit much more strongly. Yeah. No, I think it's a question for all of us to think about, right? And I'm still optimistic. At least what little bit the techno optimism is that we find other things to do on top of this, right? But then that means all of us have to be so much better. Today, what is our benchmark? It is our LinkedIn peer, right? Tomorrow, our benchmark would be AI, right? And that's a very, very hard benchmark. And so we have to figure out what we will all, and that's why I mentioned the stage also. I think we have a young country, right? We really need to think about what does this mean for a young country. But interestingly, there was actually a survey conducted across the world about how you feel about Gen AI coming. Most of the Western countries, people were very terrified of what's coming, right? In India, people were optimistic that it's a good thing, right? Because I mean, we have dealt with various kinds of things at various times as a country, right? that is possible. That is also possible. But I think this optimism that, hey, this is a tool, we'll make do with it, right? We'll see what we can do on top of it. I think will also come up, but it'll require various systemic choices, right? So, I mean, yeah.
So what do you feel now in the future? I mean, all these research analysts.
Yeah. 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 I mean, analysis, like somebody said, analysis is something I don't see humans doing, right? Especially reading 25 reports and writing an important report with all insights. That's going away. But apparently, just recently, some folks put some these models to do stock trading, right? And these models are still not able to beat human level the things there, but it's a matter of time. But I think especially things like summarization, where lots of different things need to be understood and distilled, right? I don't see, even today, the benchmarks are so high for these models, right? Those kinds of tasks will go away. So only where there is careful human intuition, lots of experience, human psyche like thing. In fact, people are already doing that. People are trying to make these models be better on what is called the theory of mind, which is a whole body of work on how humans think. Because if it goes there, then even that aspect becomes a bit hard for us to deal with, right? But we'll see. I don't have answers. We'll see. But at least what I can tell is there are huge changes coming, and this will require us to adapt at various layers. Companies have to adapt, but also, you know, education systems, etc., will have to adapt. But the positive side is you will have technology to build. Hey, how do I make healthcare better? How do I make education better? How do I make legal systems, extremely burdened system now? How do I make that better? Those kinds of problems will come up, and there'll be things to build there, right? Okay, I had something else. Yeah. Yes.
ChatGPT has certain point of time knowledge which is locked and released. So same way, Bharat also will have some type of this certain period, whatever that knowledge up till particular period is locked, and this is some version, and then so on. So how are you thinking to open it up, this Bharat LLM? What is your strategy?
Okay, by the way, Bharat LLM is being built, Bharat GPT is being built by a different team,
I'm
right?
talking about this one.
So what exactly was the question?
So how does this GPT has, ChatGPT 3, 4 has certain point of time knowledge, right?
Correct.
Stop it from there, whatever happens later, they will not able to do it. So in case of your LLM, which is Sarvam, right? So how is that you're handling that? And
so,
this can be open to enterprises also to explore. Are you in a stage where we can try and see the capability?
So our voice LLMs are already being tried out, and they're in beta. As I said, this 1 second round trip time of voice to voice, right? As I said, we don't see our models being used as sources of knowledge, right? I see the most value in building agentic systems which do actions on your behalf, right? And you're able to interface with these models, and they are able to either use knowledge from a knowledge source as an agentic behavior, or get actions done on top of APIs and so on, right? For example, if I could do flight bookings in a significantly easier way, speaking in Kannada and do it, right? That's the kind of things that we think people will build with the systems, right? Or I do a call and somebody answers things about my credit card, right? Where knowledge is separated out, actions in terms of APIs is separated out, and this LLM's role is provide a voice-to-voice interface plus the reasoning engine to interface with all these systems, right? So if you break up the problem into language plus reasoning plus knowledge, right? Then language plus reasoning is what we should expect from these models. Knowledge should come from outside, right? Right now, reasoning is there in GPT. Can we add a language layer and then make it do well in terms of accessing knowledge and other actions, right? Any other question before I move on? Yeah.
The data security, how will we regulate and protect data security through LLMs? Because this is an open topic, and okay, these examples are at least straightforward, and you know, they are everyday usage, right? But if you start using it for certain financial activities and things like that, then how do we use LLMs, and how can we protect our data communication over the channels?
Yeah, different providers have different things for that, right? See, I'm optimistic that, and where Sarvam is going, we want to work with businesses to have their own local models running on their hardware, right? And we will, of course, have our own running if you wanted a platform, right? I see, just like people had this debate between cloud and on-prem, the same debate showing up here, and people realizing that you can build open models on your own data. He gave example of Bloomberg GPT, right? Bloomberg said, let's go build a model. It took I think, close to 50 or 70 million dollars to build it. Now the price is 10 times cheaper, but more companies will be able to go build their own models and host it on-prem, right? With things like NVIDIA cards or other accelerators. That's one possibility. The other possibility is the cloud guys will be hearing this from everybody, right? That, hey, what about my data and so on? And they will build guarantees that, you can access LLMs with those guarantees in place. Yeah. Just let him come. Yeah.
What are some of the challenges other than the knowledge or data?
A lot of challenges, right? So see, these systems are fairly large systems. First of all, you need lots of compute, right, to train. That's one raw material. The other raw material is data. The third thing is that the models at this scale of billions of parameters are very finicky. Training them requires still some art of training right now, right? When we trained our models, for example, just giving some experience, suddenly you'll find that the model becomes unstable and it starts to have much higher loss, right? And you need to figure out what happened, and maybe there is some small amount of data somewhere that is noisy and it causes issues, right? So there is a lot of art involved right now, because it's not all in the open source, as opposed to a few years back when people open sourced all their research. Now it's all closed source, right? So every company needs to go figure that methodology out and train. So it's raw materials, data, and compute, but a lot of intuition on how to train these large models, right? Somebody was mentioning, but recipes are coming out. These open source codes are coming. In fact, yesterday there was today morning there's an event in Delhi where Sarvam is presenting a recipe for training Indian language models on Llama. It's an event by Meta, and we are going and sharing our experience, putting it in the open source, how you can add Indian language skills to Llama. So you don't even have to wait for Sarvam to get models. You can all get Indian language models also. I think you'll see more of this coming, but the larger and larger models, there'll always be a bleeding edge or set of ideas of how to train them and do things on top. Yeah.
When they say that one LLM is talking to the other LLM, what does it actually mean?
I mean, these LLMs can do only one thing. You can give a piece of text and they'll complete it, right? You can just daisy chain these two LLMs. Right? You can send the output of one to the input of the other and ask them to converse. In fact, that's not a bad idea. There's a nice paper by guys from Stanford where they show that you can simulate a village of 50 people, right? Each one is an LLM that's seeing what's happening, and they wake up, they go interact and so on, and you actually get patterns of how behavior emerges, right? And so it's an interesting space.
When you said costs come down a lot for LLMs now if I want to select everybody here in the room will set up their own LLM in their own PC, so how much can it cost?
See, what is happening is the very big guys, let's say OpenAI, they are able to serve this at fairly low cost because they are aggregating the demand across everybody, right? So the net utilization of hardware is much, much better. If you put it DC and run it, my sense is it will be more expensive than getting API access from some of these guys, but not by much, right? Maybe in the order of 2 to 5 times more, right? And as you build it out further, as you scale it out, those costs will start to reduce, right? Or as better accelerators, cheaper accelerators come out, it will start to reduce.
But there is nobody like so today if I want to feed in like 50 reports to ChatGPT of let's say one sector and ask it to give some output, will do that, or it's only restricted to like 5 reports, 10 reports?
No, all these models have what is called a context window, which is limited. Typically, it's about 8,000 or 16,000 tokens, meaning anything between, let's say 10,000 words at most. 10,000, by the way, is a lot of words, right? But people are building some long context. In fact, Google released Gemini 1.5 3-4 days back, where they say you can take 2 million words, right, as input. So these are coming, but the performance after a certain size, it gets worse, right? It's not like these are They do very well. After about a couple of thousand words, it becomes hard for these models to improve. But then you can always pass one document, get the summary, pass another document, and orchestrate on top of it, right? Rather than expecting the LLM to do everything. Right? Okay, so I'll just maybe, I've had much more to say, but I'll just maybe say something about one more topic so that you see what there were 2 or 3 things I wanted to do. But I just want to just give you this picture in the last 5 minutes that I have, which is that I see that how do you extract AI performance, right? I see this as being standing on 3 legs, right? All of you probably are aware of these 3 things, but I just wanted to say some things here. One is, of course, prompting, right? Which is, how do I simply say the right input prompt to GPT and get it to do what I want it to do, right? And this is underestimated. If you do better, I think people who are playing with these models would know, if you can prompt these models better, they do get better, right? In fact, you can do what is called few-shot prompting, where you can give few examples of input-output pairs, and the model would start performing better. The second is fine-tuning, which is take a model, you have your own data, on which you want it to get better, and then you fine-tune the model on that data, and then improve its performance on that. For example, somebody mentioned NLP tasks, right? If I wanted to do a certain NLP task, then I can create a data set of that NLP task, give it to this model, fine-tune it, and then use it use the model, right? In fact, today GPT models can be fine-tuned, other models can also be fine-tuned. They're becoming almost click, 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 run kind of experiences to fine-tune models. Just upload a data, click, click, run, and now you have a fine-tuned model. The final thing is pre-training, which is what we were talking about, which is starting from a model ground up. Like this Bloomberg GPT, there are other examples in the industry. What we are building now, they're pre-trained models built from scratch, because you have then made conscious choices about what data to train it and so on, right? And my own sense is that this is the full stack of AI. So most people are today in prompting, right? They're taking a very large model and prompting. And very few people are now in India starting thinking about fine-tuning, right? But I think very soon you'd find that the technology will get democratized, that most people will have to play at all the levels, right? Let's think of an IT company that's going and making a pitch to some Fortune 500 company to say, I can now give you Gen AI. And if you go and tell after 2 years, I can prompt for you, they'll say, I can prompt it myself. Why do I need you to prompt it, right? So being able to go do things like fine-tuning on very clean data, or even go and do things like pre-training on a very, very carefully selected data set, which does not have any errors in that particular domain, etc., will become the art of the product, right? If you wanted to solve a Gen AI problem, maybe build customer care for Vodafone, or as an example, then you may actually say, hey, why don't I go pre-train a model which I know to have the right values in terms of what this model should do, then ensure that it is well fine-tuned, and then ensure, of course, it is properly prompted, right? But then you own that model. That's the software stack, right? This is the front and back end of the new software stack that we should deliver. And interesting, all of this runs on GPUs, right? So in some sense, we are in a world where this is the nature of software, and it is going to be the same. The model looks the same whether you're doing something in clinical trials or something in legal, right? It looks the same. The same workload runs on the same accelerators. You just have to become good at understanding these 3 layers for that particular domain, right? And I feel that at least in India, we should, and I tell this to most people I meet, we should look to be playing as a full stack, right? And not just be looking at, and I think right now, pre-training, as I said, a little bit, there's the art of it. It's not yet systematized, but soon, I think in a matter of months to a year, you would find proper online courses. Hey, here is how you can start pre-training a model from scratch and so on. And most people should aspire to do it. Let me pause here. I had a lot more slides, but I'll leave it at this, and happy to take any questions that you may have, right? Or maybe I'll just show you one last thing, right? Yeah, maybe I'll just show you this piece so that you see what I meant here. So if you look at accuracy and cost as 2 metrics, right? Let us say if you can get to somewhere with GPT-4, then if you did RAG, which is retrieval augmented generation, people are asking about how do I ensure accuracy. One way to do that is to give it knowledge, right? And say, hey, answer this question, but assuming this knowledge, and you give 1,000 words which contain the knowledge for it, right? Of course, cost goes up because you have added 1,000 words, and it adds up to the API cost. The second thing you can do, if these 1,000 words are repeating again and again, you would not send this again and again to the model. You would go and do some, this is prompt design. If you do some careful prompt design also, probably you'll get much better accuracy at a given cost. The other important thing is this one. If the RAG piece that you're constantly having to send to the model can be systematized, you can go and actually fine tune the model. In fact, reduce the cost while improving the accuracy, right? So once you're hitting something like, I have examples which can reach 1 billion tokens a month, right? Then you're actually able to take it leftwards, reduce the cost, improve accuracy on that billion tokens, right? And many people are starting to do this, and this will become very, very systematized, right? So this is some kind of a space that you will play with. You'll start off, you'll prompt it, you'll do RAG, you'll then fine tune it. But the interesting thing is, you may do it now with an open LLM. Right? You'll say, okay, who cares about GPT-4? Maybe it's expensive. Maybe it's great. By the way, I think it still remains the best model after a year after it was released, right? And there's more happening inside OpenAI. But you might say, okay, I want to run it in my data center. I want to take a Llama or a Mixtral or some such model or some model that Sarvam builds, and I will then do all this journey, right? And I think that you would find that the accuracy is maybe a bit lesser, but with the appropriate skills, you will get the cost down, you will have data sovereignty, you'll also have teams in your companies which can then do more things with it, right? In fact, there is more. You can go pre-train your own model and also make it even more cheaper, or you can even build what is called SLM. LLM is large language model, SLM is small language model, where even with a couple of billion parameters, you can get these models to do good things. And this is, again, something that's coming up in research now. But this is what will look like the technology landscape. Right? Today, if you look at some Gartner or whatever technology quadrants, it contains all kinds of things. Right? This is what it is. It's going to become a bunch of different neural networks that can do various things, and you have to decide between whether you fine-tune it, whether you want to train it from scratch, etc. I know time's up, so I'll stop here. Yeah, thank you.
Thank you. Sure.
Correct. Yeah. I think all the companies are thinking about that. In fact, NVIDIA has prototypes of cards which fit into the cars, right? So I think it's coming soon. Yeah.
Thank you, Pratyush, for providing this interesting insight.
For more content on tech and leadership, subscribe to NASSCOM YouTube channel and press the bell icon to never miss an update.